Okay, so we are going to start with 5.1, which is adding and subtracting polynomials. You can find these notes under, if you go into Brightspace, under Content, go to Lecture Notes, and Chapter. When you click on Chapter 5 notes, all of Chapter 5 is going to come up. I'm going to only do 5.1 and 5.2 today, but all of Chapter 5 will come up when you click on this. Okay, I'm just going to let you can pause the video and you can fill in all of the missing terms here, but I'm just going to go through them really quickly. A polynomial is a single term or a sum of two or more terms containing variables with whole number exponents, meaning no fractions as exponents. The standard form of a polynomial is you order them in descending powers of the variable. So you start with the largest variable and you go down. The degree is the exponent of the variable. So if you had something like a being some number, x to some number n, the degree of this would be n, whatever that number happened to be. A monomial has exactly one term. A binomial has two terms, and a trinomial has three. Terms are separated by plus and minus signs, by the way. Degree of a polynomial is the greatest degree of all the terms of the polynomial. Terms that contain, like terms, are terms that contain the exact same variable with the exact same powers or the exact same exponents. Okay, so let's get to some examples. Determine whether the following are a monomial, binomial, or trinomial and give the degree for each. Okay, so in this particular case, here's your subtraction sign. This is your first term and your second term. It has two terms, so it's a binomial. Now, you take the highest exponent. So right here, our highest exponent is 3, so it has a degree of 3. Right here, there is 1, 2, 3 terms, so it's a trinomial. And it has a degree of, this has 0, this has 5, and this is 2, so it is to the 5th power. This just isn't in order. Okay, it's not in descending order. So right here, 9a, it only has one term, so it's a monomial. If I could spell. Okay. And it has a degree, some people are going to say it has a degree of 0, but it actually has a degree of 1 because we don't write the 1. It's really there. If we did, you can write it in there. Notice it's in red, but we usually don't. Here, I should use equal signs so they don't look like negatives. Okay, example 1, adding polynomials. Okay, you may or may not be really good at fractions. Okay, most of you are probably not. Okay, that's fine. That's why we have our calculator. We just have to learn how to use our calculators. Okay, so when we're adding polynomials, we're going to take the numbers. Let's take the ones with the same exponents. X to the third is our largest. So what we're going to do is we're going to put x to the third. And what we're going to do is we're going to add 3/7 plus 2/7. Well, you can do this on a calculator, but I hope you don't need to. They both have the same denominator of 7. And all you do is say 3 plus 2 is 5. So it's 5/7 x to the third. Now there's no x to the second, so we're fine there. We have a negative 1/5 x and a positive 1/4 x. Now again, we're not here to learn how to add or subtract fractions, so we're going to use our calculator. Okay, there's two ways to do this. If you have a newer calculator, this button right here, it's in green, it's at F1. So and I have to move this because of the glare all the time. So we're going to hit our alpha button. And we're going to hit this y equals to change it to that F1. The n over d, this is our fraction. This is a mixed numeral. Fraction to decimal, mixed numeral to decimal. And vice versa. This will go back and forth, decimal to fraction, fraction to decimal for number 4. But number 1, we are going to use negative, and our negative sign is right here. Okay, 1 on the top, 5 on the bottom. It doesn't really matter where the negative goes. You could have put it in front of the fraction. It'll work just the same. Plus 1/4. Plus, I got to hit that alpha button and this button right here. 1, hit the down arrow, 4th. And now we have, you couldn't see because of the glare. So you have negative 1/5 plus 1/4, and that gives us 1/20. It's positive. Now, to me, that takes too long to do. So I do it the old way because I didn't learn on the fraction keys. It's fine. But the way I do it is I put parentheses and fractions, and I go negative 1 divided by 5 plus beginning parentheses 1 divided by 4. The problem with this, oops, it's in scientific notation. I got to take it out by hitting mode. And I want it on normal, so it's flashing on normal, and I hit enter. To get out of this, I hit second quit. To get into it, I hit mode. To get out of it, second quit. It takes it back to the original. I'm going to hit second, enter, and bring that back up. And now it'll give me a decimal answer. Rule of thumb is if it gives it fractions, have fractional answers. So you have a fraction button by hitting math. Or you could use one of your F1 keys. But if you're going to do that, you might as well have used the fraction key. Hit enter, and it changes it to 1/20. And then we have our negative 1/3 minus 1/3. That's going to give us negative 2/3. And there's our answer. You have to be careful when it says subtracting from. This is really weird. Okay, first of all, it's the word subtract from, which means this has to go first because you're taking this and subtracting it from that. So we are starting with this 7x to the third minus 8x squared plus 9x minus 6, and we're subtracting this from it. So it's minus 2x cubed minus 6x squared minus 3x plus 9. Now, you've got to be really careful when it's, okay, that's the first thing. And they'll give this to you in my math lab where you have subtracted from. Remember, this is first, okay? Now, the next thing, when you have a subtraction sign, what you have to do is change everything behind it. You're subtracting this whole thing. So all your negatives become positive, all your positives become negatives. So I'm going to rewrite this first one. At least this is a shortcut, and I'll explain why we can do it this way in just a second. Okay, this is positive, it becomes a negative 2x cubed. This is negative, it becomes a positive 6x squared. This is negative, so it becomes a positive 3x, and this is a positive 9, it becomes a negative 9. Because there's two ways you can think about this. You can say distribute a negative sign, negative times a positive is negative, negative times a negative is positive, negative times a negative is positive, and negative times a positive is negative. Or you can put a negative 1 here and distribute it that way. Either way, any way you look at it, I just change my signs, okay, because that's what, but this is why we can do it. Now we're going to combine our like terms. 7x cubed and negative 2x cubed gives us 5x cubed. Oops, let's do circles. Negative 8x squared and positive 6x squared gives us negative 2x squared. Let's do triangles. 9x and 3x gives us 12x. And then negative 6 and negative 9 is negative 15. And we're done. Okay. Moving right along. Okay, so we've got an American Idol with polynomials of degree 2. The graph 5.2 indicates that the ratings of American Idol from season 1 of 2002 through season 9, 2010 have a mirror-like quality. This suggests modeling the show's average number of viewers with a polynomial of degree 2. Because see, it kind of makes this arc like this, okay? That tells you that it has a polynomial. It's called a quadratic, which we'll learn later, but that has this kind of shape. So some mathematician came up with the arc, the polynomial that makes that shape, and this is what it's given. We don't have to worry about that. We don't have to know that, okay? So excuse me, sorry. Anyway, if you plugged in 0 into this equation, you'd end up with 6.78. If you, like season 4, okay, if you plugged in 4 into here, you probably would have 26.4, okay, and so on. So that's basically all that's showing you right here. Sorry, I was pointing up here at season 4 with Carrie Underwood, 26.4 million viewers, okay, and you would have that about right there as well. All right, so now it says graph the equation y equals x squared minus 3. Select integers for x starting with -3 and ending with 3. So we're going to go -3, -2, -1, 0, 1, and I guess they were doing -3, -1. Let's do it that way, because that way it gives us, we could have gone and made our own columns, but they really didn't tell you, you know, which ones to use between -3 and 3. So let's make it symmetrical. You don't have to. You could have used the number 2 if you prefer. So what you're going to do is you're going to take this -3 and you're going to plug it in for x. Now you've got to be careful if you're going to use your calculator. You have to put negative numbers in parentheses. -3 to the second power minus 3. Because if you don't, you're going to get this answer wrong. -3 to the second power gives us +9. Minus 3 gives us 6. So our point is -3, +6. Okay. If you do not put that in parentheses and you do this, -3 squared minus 3, you're going to end up with -12. And that's wrong. Because again, this here, you have to have it in parentheses. Notice this gives us something totally different. That gives us a +6. Now, there's a way around this that you don't have to worry about that. I like to use the store button a lot. I teach my class how to use the store. Now in this case, we have -3. I'm going to take negative, I'm going to hit -3, and I'm going to use this STO button right here. Sorry, the screen's so small, I have to keep moving my calculator up and down. And I'm going to store it under X. And I'm going to hit enter. Now, anytime you type in X, when you use this button right here, that's your X button, it's going to say, okay, we want it to be -3. So now all I have to do is plug this x squared minus 3. Hit x squared minus 3, and you'll notice that it gives us 6. See, I don't have to worry about it. I can do it either way. So let's do -1 now. Let's store -1, hit -1, store x. And when you do that, it looks like this, and hit enter. Now, I can arrow up until it highlights this. I don't have to retype it, and hit enter. It brings it down, and now we're going to get -2. Because -1 squared gives us 1, minus 3 gives us -2. So our point here is -1, -2. I'm not going to do it the store anymore. You can do it if you want to. But 0 squared is 0. Minus 3 gives me -3. Sorry, my phone's going off obviously. And so this point is 0, -3. Now 1 squared is 1, minus 3 gives me -2. So the point is 1, negative 2. And then 3 squared is 9, minus 3 gives us 6. I have a feeling my phone's going to go off again because it was Connor, and he doesn't know I'm doing a video right now. So he'll call me back. Negative 3, positive 6. I'm going to go in the elevator to negative 3, up to 6. I'm going to go in the elevator to negative 1, down to negative 2. I'm going to go, I'm not going to move in the elevator. I'm just going to go straight down to negative 3. I'm going to go in the elevator to 1, down 2. And then I'm going to go right 3, up 6. And again, if it's an x squared, it's going to be a parabola shape. It's rather going to be a hill or a valley. Okay, this is what I call a hill. This is what I call a valley. Okay. And that finishes up 5.1. 5.2, I will do another short video for it.